The very first one up there. What am I going to do with my exponents? No. What do you mean by combine them? Put them together. No. What is x squared times x squared? That's a bad example. What is x to the first times x squared? X what? Cubed. Because 1 plus 2 is 3. Whenever you multiply like bases, you add the exponents. Okay. So whenever you multiply like bases, you add the exponents. So common sense would tell you, whenever you divide like bases, and I'm jumping around up here. Whenever you divide like bases, what are you going to do with the exponents? Subtract them. Alright, going back up to the top, this may be one that you didn't learn, but it's not that hard. Whenever you have a power raised to a power, okay, so a to the power of m to the power of n, what do I do with the m and the n, the two exponents? Multiply them. Alright, quick example of that is if you have x cubed to the power of 4, that would be the same as x to the 12th. 3 times 4 is 12. Whenever you have two, it's the product to a power property. Whenever you have these parentheses and you've got an exponent, you got multiple things inside that parentheses, that exponent belongs to both of them. Alright, the example where most people mess this up is something like this. Okay, that 2 not only belongs to the x, which is everyone remembers that one, but you've also got to put it to the coefficient. Okay, a lot of people will mess that up. The next one, this is again probably one you hadn't done. This is the easiest one that's on the board. Anything to the power of 0 equals what? Who said 1? It is 1. Anything to the power, you're not multiplying it by 0. Anything to the power of 0 is 1. Okay, it does not matter if it is that is going to equal 1. Okay. This next one, dividing different bases, very similar to this. That m is going to belong to both the numerator and the denominator. Okay. And the very last one, the negative exponent property. This is kind of one of the big ideas of today's notes. Anytime you have a negative exponent, you're going to move the negative exponent and its base. All you're going to do is you're just going to move it to the other part of the fraction. Okay, so you got to kind of see whole numbers as fractions, just whatever it is over 1. All right. So the next one, it would just be 1 over a to the power of n. Okay, now both of these get moved to the denominator. If you start off, or if you have a problem with a negative exponent in the denominator, so I'm going to add kind of an extra example here, because I said you move it to the other part of the fraction. That is the same as moving that to the top. And you don't have to have over 1, but you can. Okay, so that would be the same as that. Questions on any of those? We're going to go through, on the next page, we're going to go through some examples. Each one of these examples, they have multiple properties on each problem. Okay, so we're going to walk through a few of these. And I'll zoom in for... Okay. Now, one good thing about these properties, on the last unit we had, especially with the graphing and stuff at the very end, the order in which you did it was very important. If you do the properties correctly, it doesn't matter which order you do it in. Okay, in fact, you'll probably see me do certain, 2 different problems that have maybe the same kind of properties, but I do them in different orders. But the one thing that I will normally try to do first is I will try to get rid of any exponent. So looking up there at 1, if I have n cubed to the power of 3, what is that going to become? N to the power of what? 9. 3 times 3 is 9. Then I've got times 2n to the power of -1. Now I've got a negative exponent. I've got to move I've got to move the negative exponent and its base to the denominator. What is its base on this problem? Is it n or is it 2 and n? Just n. It would be 2 and n if it was that. Okay, if there's no parentheses, the exponent only belongs to the nearest base. If there's parentheses, it belongs to every base that is in the parentheses. Okay, so what that means is the 2 is going to stay up there, up in the numerator. And then I'm going to have n to the power of 1, or just n, in the denominator. Once I do that, I'm essentially multiplying 2 fractions. Okay, you can just make that n to the 9th a fraction. And I'll just multiply straight across. So I've got 2n to the 9th over n. Can I reduce that part of the fraction? Do what? 2n to the 8th power. Because that's just the dividing like basis. So I would subtract the exponents. 9 minus 1 is 8. Alright. Number 2 is really good because it's a simple example of a common mistake that a lot of people make in here. On the first 2v, is that squared attached to the 2 or the v or both? Both. So what is 2 squared? 4. And then I would write v squared. On the second one, is it attached to the 2 or the v or both? Just the v. And now I'm just going to multiply. Whenever you multiply, do one thing at a time, okay? First, and especially on problems like the next one. So, 2 times 4 is 8. V squared times v squared is what? V to the power of 4. Why exactly? Because you add them. Make sure you're not multiplying 2 and 2. 2s are a bad example for this stuff. Okay? So looking at the next one, and there is a lot of that, because there's no parentheses on this, so I don't have to worry about the power to a power stuff. I do have a negative exponent. Normally, unless it's -1, and you'll see that down here on 7. If it's something other than -1, I will do the negative exponent at the very end. Okay? I wait, I do all the other work. If I got a negative exponent, I move it, and that's my answer usually. Okay? So I'm just going to do multiplying like bases. So first I'm just going to multiply all of the coefficients. What is 2 times 4 times 3? 24. Okay. Next, what is x squared times x squared times x? X to the 5th. After that, what is y to the 4th times y to the 4th? Y to the 8th. Over. And I'm just going to go ahead and write everything down there. Nice and color coded. Probably because I wrote it wrong. Okay, so now I've got dividing like bases. So first, always do the coefficient first. That's going to be the easiest part. 24 divided by 3 is what? 8. Okay, and then I'm going to have x to the 5th divided by x to the power of negative 3. So what is 5 minus negative 3? 8. If you have to write that out, do it. Okay, negative, negative, that becomes a positive. So I've got x to the 8th. What is 8 minus 2? Okay. I want to see if you can try to do 4, 5, and 6. And then we'll do these last three. Last three won't take long. Oh, let me make some room there. And I'm going to multiply that by m squared. All of that is over 1. Whenever I move everything, if everything in the numerator moves to the denominator, then 1 is the numerator. Then what is 2m squared times m squared? 2m to the what? 2m to the 4th. 8 and 9 are probably the two easiest ones up here. What's the answer to 8? 1. What's the answer to 9? What does this one turn into? 1. What's this times 1? Do what? X to the 4th, y cubed. I'm just going to talk about these bottom two real quick. So if you'll just kind of look up here and pay attention, and we'll move on to something kind of new. Once you do a few of these and you've practiced this stuff, it gets pretty easy because we're not going to see a lot of stuff with really, really complicated numbers. Okay? And just make sure you haven't forgotten your basic geometry. How do I find the area of a rectangle? Multiply them. What's 2 times 2? 4. What's 4 plus 2? 3 plus 1? 4. So it's 4x to the 6th, y to the 4th. If you have the area and you're given one side, how do you find the other side? Divide. 8 divided by 4 would be 2. X to the 5th divided by x squared would be x cubed. Y to the 4th divided by y cubed would just be y. So the operations are going to be very simple. You just got to know whether you're really only doing 3 of them. You're adding, you're subtracting, and you're multiplying. There's not going to be a whole lot of dividing. Alright, so go to the back, or the next page. If you do not have a calculator, you need to go grab one. So, on these right here, Kate Sutter, will you put that first one in? Tell me what that is. Holly, will you do the 81? Just tell me what it equals. 4 to the power of 1/2. Casey, do 64. Reese, do the 100. And Nick, do 25. Everybody else, pick another one, a random one, and do it. And see if you got it. Do what? Some of them. Freaking genius. 4 to the power of 1/2 is 2. Holly, what'd you get? Working on it still? Whenever you get your answer, just yell it out.
I got 10.
You got 10? 5? Holly, did you get yours? Eight, and then Holly got 9. Okay. What do you notice about the answers? Square root of the what? What is this called? Someone just said it right here. The base. So your answer on these is the square root of the base. This is true if you are raising something to the power of 1/2. It has to be 1/2. So whenever you see those, they should be pretty easy. You shouldn't need your calculator. What is 16 to the power of 1/2? 4. What is 49? What is 36? Okay. So 1/2 should be pretty simple. Okay. Get those written down. Let's go down. We're going to talk a little bit about 1/3. Before I move on, I need to make sure that you're aware of this expression. So, on this page, we're really talking about rational exponents. Let's make sure we know what that means. Rational is a fancy word for what? Fraction. Exponent is the power, the little number that's up there. Some of you call it, okay? So whenever I say that we're talking about a rational exponent, that is something, so a base, being raised to a fraction. Okay, that's all that means. Rational exponent just means you've got a power that's a fraction. That's all that means. You need to know that because here in a minute we're going to talk about a process that I refer to rational to radical or radical to rational. So when I say rational, that's what I mean. You have a rational exponent. Alright? So let's come down here. So on this, Catherine, do 2 cubed for me. Lisa Betta, do 4 cubed. Austin, do 5 cubed. Trevor, do 8 to the power of 1/3. Jessica, do 64 to the power of 1/3. And Jen, do 125 to the power of 1/3. I forgot it there for a minute. I was about to put something else. I froze. And we're going to put Sutter.
He keeps hitting it over.
You need to put it in first. And then do the fraction.
Oh my god, why is mine so big and red?
Whenever you get your answer, let me know what you...
64. What number is this? 195.
Yeah.
Can I go after?
2.
Do it.
120
Bathroom.
bucks.
Can you wait?
What?
Can you wait?
I don't know what you said.
Can you wait? What'd you get, Austin?
120 bucks.
Good job, Austin. Can you hold off for just a little bit? Especially, you need to be here for this stuff. Whenever you get it, just yell it out. Got an 8. Yes, Coach Howard. I do. Oh, okay. All right. That is wrong. 125 to the power of 1/3.
It says 3.
That's, I said to change it to 1/3. That's why it has 1/3. Jessica Kaufman, you're leaving. Okay. Alright, so looking at this. What do you know about the answer, or what do you notice about the answers? Well, let's look at this first. What do you notice about the answers over here?
The same as the other side.
No, don't look over here. Nope. If raising something to the power of 1/2 is the same as square rooting it, raising something to the power of 1/3, that is going to be the same as cube rooting it. Cube rooting the base. Okay? And to connect the two different tables that we have there, you need to know that the cube root, if you cube root something, that is the opposite of raising something to the power of 1/3. So, like I said, the cube root is the same as raising something to the power of 1/3. Those are the same. So coming down here, this is what I'm talking about, rational to radical. Let's talk about radical for a second, because you need to know that this is a radical, not necessarily the square root. Okay? Whatever number is here, okay, that could be cube root, that could be 7th root, 17th root, whatever. If nothing is there, it's an understood 2. Okay, that's why a lot of people just think it's square root. But this is a lot different than this. The first one is the cube root, the second one is 3 times the square root, which is completely different. Cube root, that means there's 3 roots. Okay, the square root of 16 is 4, because 4 times 4, 2 4s, square root, 2 roots is 16. The cube root of 64 is 4, because cube root, 3 roots, 3 4s. 4 times 4 is 64. Okay, I think a lot of people get lost with that, whether it just hasn't been explained to them, or they thought it was nap time at the time it was being explained. So, alright, so looking at this, we're going to talk about going from rational to radical, or radical to rational. And I'm going to do this a little bit different than the way it's written. And I'm going to have you write it really big and almost awkward. But I want you to rewrite that as A to the power of M over N. And I've had a little bit more success of explaining it like this than the way it explains it on the other side of the notes. Okay? But a lot of times you're going to be asked to go from rational to radical or radical to rational, and you're just rewriting something. It's going to equal the same thing. It's like saying 0.5 is the same as 1 over 2. Okay? Whenever you do this, and this is going to look really weird at first, I want you to think of 3 different levels. And if I go from radical, this would be rational to radical, you're going to keep all of those on the exact same level. And if you're going in the opposite direction, then it would just, if you were given the problem in radical form, and you had to write it in rational form, you could just move them over. Okay? So an actual example of something you would see. So this, that would be the cube root of 4 to the power of 2. You just would slide it. Think about just sliding them all over. You just got to know where to stop them, really. Okay? So. You can do it that way. Or you can look at it this way. This gets a lot more into the math side of it, but your numerator, that you can change that to the exponent by something, and then now you've got the a to the power of 1 over n. Well, if that's 1/2, then that turns into the square root of a, or if it's 1/3, the cube root of a, or whatever. Okay, so I think the other way is just a lot easier. All right, so if I'm going to go from either rational to radical or radical to rational, I can do the same process. So if I've got x to the power of 3 over 4, Emma, and I wanted to write that in radical notation, what would that look like? What's under the radical? And what's the exponent? Okay. All right. We also need to practice knowing how to say this, because three of the problems on the homework is something in radical form, just in words, and it asks you to write it. Okay, that would be the 4th root of x to the power of 3. Okay, this would be the 5th root of x to the power of 3. The square root, you wouldn't have to have the 2 there, but the square root of 2 to the power of 10. Alright, so Trent, if I had this in radical form and I wanted to write it in rational, what would that look like? Okay. 3 over x to the 5th. Okay. What's my base? What's my exponent? Okay. So x to the power of 3/5. Alright. Catherine, what would the next one be in radical notation? How many roots?
9.
Okay, so the 9th root of to the power of 5. Alright, Trevor, what would this be in rational form? to the power of?
2. Oh, you're saying what's on top?
Yeah. Oh.
10 of 2.
Okay. That could just as easily be written as 5. X over 5. Or x to the 5th power. Okay. Alright, last little table. It says to use your calculator. Do not use your calculator. Because you don't need to. You just got to think through it a little bit. Okay? If I told you what is 2 squared? 4. But if it's negative 2, where's that 4 going to go? Do what? No. Where? The denominator. Okay? Remember the negative exponent rules. 2 squared is 4. The negative just tells me, hey, the 4, all that needs to happen in the denominator. Okay? And we can write it in steps here if you want to. That's all that means. Okay, so if 4 squared is 16, then 4 to the power of negative 2 is going to be what? 1 over 16. So if you know what any number squared, if you know what that is, you should know what that number is to the power of negative 2. Because you're still going to have that number squared, it's just 1 over that. So 5 to the power of negative 2 would be what? 1 over 25. 10 to the power of negative 2 would be what? 1 over 100. Okay. Very similar idea here because kind of ignore the negatives up here right now. Whenever we raise something to the power of 1/2, that was the exact same as doing what? Take square rooting the base. Well, whenever it's negative, all that means is I need to take the square root of the base. It's just all that needs to happen in the denominator. That's all that means. Okay, so if you just kind of decode it, 1/2 means square root, the negative means put it in the denominator. So the next one would be 1 over the square root of 4, which if it is a perfect square like 4 is, you could just go ahead and take the square root of it and make it 1 over 2. Okay, so Brianna, what would be 5 to the power of negative 1/2? 1/2 tells me to do what to 5? Nope. Casey? Do what? Square root. So 1 over the square root of 5.